Next topic is electrolysis. Passing electricity through solutions, electrolytic solution. Passing electricity through electrolytic solution. Using 2 electrodes and 1 electrolyte. Electrolysis. In junior classes, we have learned electrolysis. Many times we have learned electrolysis. Here, we will be doing little bit calculation. Suppose I have taken one copper electrode. Here again copper electrode. Thin strip of copper. Thin strip of copper. This is impure. And this thin strip is pure. Negative electrode. In electrolysis, negative electrode is and positive electrode and. Anyway, whether it is electrochemical cell or electrolytic cell at anode oxidation. Whether it is that old electrochemical cell where chemical reactions produce electricity or electricity produces chemical reaction. Both the cases, anode by oxidation. Oxidation will take place. Oxidation will be taking place at anode. Now, this is an impure metal. Purposefully, I have taken that impure metal because in junior classes you learned that electrolytic refining. For that, we use the same thing. What happens at anode? Oxidation takes place. That means Cu changes to Cu2 plus and electrons. Oxidation takes place at anode. These Cu2 plus are entering in electrolyte CSO. CSO4 solution is electrolyte. Its own soluble salt is dissolved in water, and that is this aqueous copper sulfate solution. When the one Cu changes to one Cu2 plus, an equivalent amount, that means one Cu2 plus from here will get reduced. It will be taken electrons and get that positive electrons. Similarly, Cu will be taking more and more. Cu will be changing to Cu2 plus aqueous. Plus aqueous means that is in the that is along with water. Ions in water. Cu changes to Cu2 plus aqueous. When one Cu changes to Cu2 plus an equivalent amount of it from the solution, one Cu2 plus undergoes reduction and changes to metalic Cu, and that metalic Cu. I told this is impure metal or impurities, uncharged. Impurities will be falling. Impurities will be falling as anode 1. Anode. You can take other metals also here. Suppose you want to electroplate it. You know many gold ornaments. Electroplated. Inside some other metal, outside it is gold. Nowadays, 1 gram ornaments, 1 gram gold, 1 gram gold ornaments are very much famous. Only the outer portion is covered with the gold. So that is done by electrolysis. The copper can be plated with gold. We have to take the gold electrode here. So this can be used for electroplating. This is the method used for electroplating. Electroplating, during electroplating, this metal rod will be evenly coated. Evenly coated. If you paint, you will see marks in between. That brush bristles mark will be there. But if it is electroplating, it is evenly coated. You cannot make out that inside is some other metal. You cannot make it that inside. Okay, so here at anode oxidation takes place, at cathode reduction. At cathode reduction takes place. How much electricity you are passing through this? That much amount of copper will be. So, Faraday's first law, Faraday formulated two laws. Faraday's first law stated the amount of copper deposited will be directly proportional to the quantity of electricity passed through it. The amount of the substance liberated or deposited, same meaning. The amount of substance liberated or deposited is liberated, that is deposited. The amount of substance liberated or deposited will be directly proportional to the quantity of electricity passed through. How can we find out the amount of substance liberated or deposited? Before putting this thin rod inside this, take the weight. After passing electricity for some time, you take it out and again you wait. The difference will give you amount of the substance deposited or liberated. So this is electrolysis. We are going to the quantitative aspects of electrolysis. See, one copper nucleus requires 2 electrons to form the deposited seal if only one atom of copper is deposited. You cannot touch one atom, you cannot see one atom, you cannot handle one atom of copper. So for us, there should be some amount to be handled with. For copper, there is a special number. Look at the molar mass of copper, that is 63.5. 63.5, if I take that number, that means 1 mole. This is only one atom. So to get that 63.5, I know some number about copper, that is only the molar mass. In terms of mass, I have only one number, that is 63.5. Here, this is one atom. One atom is useless for me. I cannot do any calculation. So I am thinking of 1 mole. 1 mole. 1 mole means 6.022. 1 mole means 6.022 into 10 to the power 23 atom. If I get these many atoms, then I can write 63.5 something quantitative in my hands. So, to get 1 mole of copper atoms, I need here 1 mole of CO2. So, now I am considering 1 mole of CO2. For 1 CO2 plus, 2 electrons are required. So, for 1 mole of CO2 plus, how many electrons are required? 2 moles of electrons are required. 1 ion, 2 electrons, 1 copper atom. 6.022 into 10 to the power 23 ions. To double electrons, that means 2 into 6.022 into 10 to the power 23. Then I get 6.022 into 10 to the power 23 ions. 1 ion, 2 electrons, 1 ion. So 1 mole, 2 1 mole of copper plus ions, 2 moles of electrons. That time I will be getting 1 mole of 1 mole of Cu2 plus requires 2 moles of electrons. Come to those electrons. We are going to convert these 2 moles in terms of electricity. 1 electron charge is 1.6 into 10 to the power minus 19 coulombs. 1 electron charge is 1.6 into 10 to the power minus 19 coulombs. That is 1 electron's charge. 1 mole of electron's charge. That means 6.022 into 10 to the power 23. This much charge, this much coulombs is called 1 Faraday. Right? This much is called 1 Faraday. 1 Faraday means if you calculate, you will be getting 96,487, but you will be taking it as 96,500 coulombs approximately. 1 Faraday is equal to 96,500 coulombs. But here, not 1 mole, there are 2 moles. 1 mole electrons per charge is 96,500 coulombs. So here it will be 2 into how much coulombs? 2 into 96,500 coulombs, or I can write 2 Faraday. So to make 63.5 gram of copper, to get 63.5 gram of visible. To get 63.5 gram of copper, I need how much electricity? 2 Faraday. 2 Faraday means 2 into 96,500 coulombs. This is the relation between charge is electricity and amount of copper deposit. If you pass this much electricity, 2 Faraday electricity, you will get 60.5 grams of copper, provided enough of substance in it. This is the relation for copper. Now you consider aluminum or silver or magnesium or sodium. Other atoms in case of copper, 2 Faraday. Let's consider silver. Let's consider silver. Silver ions should change to silver metal. 1 silver ion requires 1 electron. So you will get 1 silver atom. 1 silver atom you cannot see, you cannot handle. We should have some amount, some quantity, some visible quantity to handle it. So I am going for silver's molar mass. Silver's molar mass is 108 grams per mole. 108 grams per mole. That means for 1. So I will be considering 1 mole there. So here I have to consider 1 mole of silver ion, 1 electron. So here it is 1 mole of silver ions required, 1 mole of electrons. So I will get 1 mole of silver means 108 grams of silver. This is the relation. Or to get 108 grams of silver, 1 Faraday is required. 1 Faraday electricity is required. 1 Faraday means 1 into 96,500 volts. So this is the relation for silver. Now consider aluminum. To get aluminum deposit, 1 atom of aluminum will be obtained from 1 Al3 plus ion. 1 Al3 plus ion. 1 Al3 plus ion requires 3 electrons. 3 plus 3 electrons. So I'll get 1 atom. One atom I cannot see, I cannot handle, I cannot touch, I cannot weigh. So I am going for aluminium soda, that is 27 grams. 27 grams means that 1 mole. 1 mole will weigh 27 grams. 27 grams per mole is the molar mass of aluminium. That means I have to consider here 1 mole air plus, right? I have to consider 1 mole air 3 plus. So here, how many Faradays? 3 Faradays. 3 Faradays, 3 into 96,500, simple. 3 into 96,500 coulombs will give you 27 grams, provided all other conditions are, uh, all other required conditions are present. Means that much amount of impure metal present. Okay. So this is the relation. So here 3 Faraday, 1 Faraday, 2 plus 2 Faraday, like this. Now this is the relation, but they can pass any amount of quantity of electricity, how much they are passing through this electrolytic cell, that is given by Q is equal to current in ampere and time in second. Current in ampere and time in seconds. So the amount of electricity passed, either they'll be giving this much ampere is passed for this much seconds. So what is the quantity of electricity? You calculate like this. You know that I is equal to Q by T or Q is equal to I into T. So you calculate the amount of electricity. The electricity what is required is this relation. So suppose they are passing 3 amperes of current for 1 hour. 3 amperes of current for 1 hour. You have to take in seconds. So 1 hour means 60 minutes. 60 into 60. That much seconds. Okay. So 3 amperes current for 1 hour. 1 hour. 1 hour means 60 minutes. That is 60 into 60 seconds. So this much coulomb. This much coulomb. Yes, if it is aluminum, what is the relation? This will give this much. So by unitary method, this will give how much? That is the relation. Or in the case of silver, this will give 108. This much coulomb will give 108. So this much will give how much silver? This by unitary method. So you can find the amount of the metal by passing the amount of, you know, whatever may be the amount of electricity, accordingly you calculate by unitary method. So for each and every metal, write an equation like this. Aluminium 3 plus, most common oxidation state. Aluminium है तो 3 plus, copper है तो 2 plus, Mg है तो 2 plus, silver है तो 1 plus, sodium है तो 1 plus, like that. So this oxidation state, what are the familiar oxidation states will be? And from the question you can make out the oxidation state. Okay, write down Faraday's first law. Faraday's first law of electrolysis. The mass of any substance, the mass of any substance deposited or liberated the mass of any substance deposited or liberated at any electron, at any electron, at any electron is directly proportional to, is directly proportional to the quantity of electricity, the quantity of electricity passed through the electrolyte, passed through the electrolyte. Passed through the electrolyte. What you have written, the mass of any substance deposited or liberated is directly proportional to the quantity of electricity passed through the electrolyte. Right, one question. What is the mass of copper deposited? What is the mass of copper deposited? At cathode. At cathode. When a solution of copper sulfate is electrolyzed, when a solution of copper sulfate is electrolyzed for 10 minutes, for 10 minutes, with a current of 1.5 ampere, with a current of 1.5 ampere. Once again, what is the mass of the copper deposited at cathode? When a solution of copper sulfate is electrolyzed for 10 minutes with a current of 1.5 ampere. Cu2 plus 2 electrons gives, first you write this equation, right? Hexofaraday gives 60.5 grams of copper, that is 2 into 96,500 will deposit 63.5 grams of copper. How much we said? 1.5 ampere in 10 minutes. So Q is equal to I into G. I is 1.5 into G is 10 minutes means 10 into 60. So this much coulombs. This much coulombs. So here this much coulombs gives that. So 1.5 into 10 into 60 coulombs will deposit how much? 3.5 upon 2 into 96,500 into 1.5 into 10 into 6. This much gram of copper will be 1.5 into 10 minutes into 6. So this much copper will be. So here it is 2 farad, 2 electrons in this 2 farad. If it is 3 electrons, 3 farad. If it is 6 electrons, then 6 farad. To get 1 mole of that. Next question, consider the reaction. Consider the reaction. Consider the reaction. Our famous reaction dichromate. Cr2O7 minus. Cr2O7 minus. Is 2Cr3 plus 7H2O plus 14H plus 6 electrons. One Cr2O7 2 minus requires 6 electrons. That means 1 mole of this will require how much electricity? Write the question. What is the quantity of electricity in coulombs? What is the quantity of electricity in coulombs needed to reduce 1 mole of Cr2O7 2 minus 1 mole of Cr2O7 2 minus. What is the quantity of electricity required? What is the quantity of electricity in coulombs needed to reduce 1 mole of Cr2O7 2 minus? See, one ion requires 6 farad. 1 ion requires 6 farad. So 1 mole requires 1 ion requires 6 electrons. So 1 mole requires 6 farad. 6 farad means 6 into 96,500. 6 into 96,500. Coulombs. 1 ion requires 6 electrons. Cr2O7 2 minus dichromate ion. This is dichromate ion. 1 ion requires 6. Okay, so 6 farad means 6 into 96,500 volts. The next question. When a current of 0.75 amperes is passed through CuSO4 solution. CuSO4 solution for 25 minutes. For 25 minutes. 0.369 gram of copper is deposited. 0.369 gram of copper is deposited at cathode. Calculate the atomic mass of copper. Calculate the atomic mass of copper. Atomic mass of copper. That is that when do we get this atomic mass of copper? That is 63.5 gram. When 2 farads are passed, that means 2 into 96,500. Means you have to calculate the amount of copper deposited for 2 into 96,500 coulombs. The amount deposited for 0.75 ampere when passed for 25 minutes, that is that amount is given. Now you have to calculate for what? For 2 farads. For 2 farads, how much copper you will be getting? That is the atomic mass of copper. you will be getting in grams per mole. You change that grams per mole into U, then you will be getting that. So you calculate for 2 into 96,500. Thank you.